Hey guys, welcome back to CMTEQ channel in this series of tutorial on Arduino and Raspberry Pi interfacing. Now in this tutorial, we're going to write yet another interactive program between the Raspberry Pi and the Arduino. So the way the program is going to work is basically we're going to be displaying the counter value on the Raspberry Pi with our Python script here. Okay, so when the counter reach a certain value, the value that we're going to determine, it could be either 5, 10 or whatever counter value you want to set. So once it reach that set limit, we want to reset the counter. But because the counter variable is being incremented from the Arduino, we then need to send the Arduino the instruction saying, okay, well, the counter value here have already reached a value that was set. So we want to reset it. Then we send a resetting instruction to the Arduino. The Arduino will receive the resetting instruction from the Raspberry Pi. Then it's going to reset the counter and it will continue on and on and on. Now there is a lot of way you can implement this in a practical way, but this is just one way of showing, another way of showing that the Arduino and the Raspberry Pi can indeed properly interact in an asynchronous bidirectional communication. So the keyword here is asynchronous. Asynchronous meaning the one person send the instruction, which will be the Arduino, then the Raspberry Pi will take the instruction and react to it and send a response. One practical example of this will basically a WhatsApp messenger. So you send a message, the message is sent, one tick, second tick, and then it gets a blue tick. The reader read the message and then he respond to the message. So that is a practical example of an asynchronous communication system. Now stay tuned until the end of this tutorial. You're going to see how we're going to implement this asynchronous communication between the Pi and the Arduino. And once again, if you find this tutorial useful, please guys subscribe to CMTEQ channel and give this tutorial a thumbs up. That will be highly appreciated. Alright, so first off, we basically going to modify this script here. This is a program we've written over the previous tutorial. So I'm going to basically just modify it. And I'm going to change this to a variable counter. And I'm going to initialize the variable counter to be equal to 0. Now, I'm going to leave the LED there because I might still use the LED to illustrate something. So I'm not gonna need the analog input anymore, so we can just change it. The LCD showing standby, okay, we can still leave that running, because when I reset there, we can see that we got standby there. So I'm going to leave that. Okay, now we're going to do the counter in every second. So basically we're going to increment a counter every second, so we can still make use of the millis function to increment our counter. Now basically we just need to change the name of our millis function here. So this can just be previous increment. So we can say previous increment. Right, so we've got our counter delay and we've got the previous increment time that's going to be held so that we can execute the counter without delay, without using the delay function. Right, after the setup, we then enter the loop function. Then we need to create a function that is going to do the counting for us. Now, as we can see, we've got a streetlight control function that we wrote here, that we are basically checking or taking a light measurement after every second without using the delay function. So basically we can just use this function to do our counter. So I'm going to just modify this function, or rather rename this function, and then I'll just call it counter function. So this is a counter function. So basically I'll copy this and rename the whole function there. So now this is a counter function. Now inside the counter function here, we are declaring a variable millis. I've already explained this piece of code on my previous tutorial. Okay, so then since we have actually changed the variable name, so there is counter delay and previous increment, so we need to change here. So this is previous increment, okay, and this is counter delay, previous increment. Right, Now we are no longer doing the light measurement. We can just chop that one off, and here we basically just going to send the counter variable. Now remember, the counter variable was already initialized there to be equal to 0. Now after sending the counter variable, we can then go ahead and increment the counter variable. Okay, so which means the next time we come, the counter variable now got a value of 1, and then we're going to send that 1 to the Raspberry Pi. Now right after incrementing the counter variable, we've got a receive data function. This function is basically here to get whatever we are getting from the Raspberry Pi. As you can see here, we've got a send data function from the Raspberry Pi, and we're sending on and off instruction that was to turn on and off this particular LED. So this is where we're handling it. So now we're going to receive instruction from here also, but this time is going to be resetting the counter instruction. So now this variable MSG pi here that we have left here, okay, that is a string variable that I declared there. So this is now going to be used to store the variable that is going to be for the resetting instruction. So if the message from the Raspberry Pi is equal to reset, then we want to delay for 1 second. Okay, so I'm going to cut and paste the delay there. We want to delay for 1 second. After delaying for 1 second, then we're going to reset the counter by just saying counter is equal to 0. After that, we clear the LCD and we want to display reset on our screen. Right, so we do not need this other LCD command, so I'm just going to clear that. Now here we've got an if statement inside another if statement, so we'll come back and fix it. So what basically I want to do here, right after incrementing the counter variable, we want to blink the LED every time we increment the counter variable. We basically want to display the counter. So what I'm going to do, I'm going to write another function here. Basically, I'm going to call this function display counter. Then I will come here and just create a function void display counter. Okay. Now here in this function, I want to do two things. The first is to display the counter variable onto the LCD, and the second is to blink the LCD every second. Now I'm going to paste what I copied into the receive data function. Right, so then here basically I'm just going to now display the counter variable. So we're gonna display the counter variable. Let's remove the delay. Okay, so we want to display the counter variable. So we clear the LCD. After clearing the LCD, we then going to write a message that's going to say counter. Okay, so we're gonna say counter, then this can go away, and on the second line of our LCD we then going to pass the counter variable. Okay, so that's going to be just counter variable like that. Right, okay, so let's just format this here so that it can be all right. Now the next thing is we want to also blink the LCD while we are incrementing the counter. Now because we are basically incrementing the counter without delaying, so we do not want to introduce another delay here. We are only introducing the delay function here after receiving the message from the Raspberry Pi, okay, that we need to reset. So we can basically just change that to 500 milliseconds, so half a second. But here we don't want to introduce a delay, so we're going to also blink the LED without a delay. So in order to do that, we have to go up, okay, and here we're going to create another variable. So that is now going to basically hold the state of the LED. So we're going to say int LED state, right? LED state is equal to what? Is equal to low. So that is a state of our LED. Now you can see that we already writing a digital low to the LED. So basically on startup, right, when we reset our circuit, we can see that the LED is staying off, right? That is because of this line here. Now we've got the variable called LED state. Now that variable, we can basically just pass it here. We can just pass the variable LED state right here, LED state. Okay, now where do we change the LED state? Now, because we want to blink without delay, so we need to just write a quick script here that is going to be dealing with changing the LED state. So what we're going to say, well, if LED state is equal to low, right? So if LED state is equal to low, now we're going to change the LED state to be equal to high. LED state to be equal to high. Now remember, this is going to happen after we go through the 1 second timer without the delay. Then we check what was the previous LED state. Now, as you can see, we have already set the previous LED state here to be equal to low. Okay, after we've gone through the 1 second without the delay with the millis, right? Then we're gonna check the LED state. So if the LED state is low, then we set it high. Okay, else, okay, we're going to put the LED state to low. Okay, so these are the only state we have available, right? So this is what we're doing. So if LED state is equal to low, then we put it high, else it must stay low, and then we just pass the LED state here. And this basically going to give us the feeling of blinking our LED every 1 second, because we only coming here every 1 second after these millis conditions have been proven to be true. I've already explained it on the previous tutorial. Right, now here, to come back here, we basically have this if statement, and we've got another if statement here. So we just have a nested if statement. So I think everything is fine there. We can try to compile this code, see if we're not gonna get any errors. Compilation. Okay, done compiling, no errors. So let's load the program into our Arduino then. Loading the program into the Arduino. Well, we can see there are things are happening here. So the counter is counting. Okay, we got a counter variable is incrementing. Now this is only going on and on. So basically we are not receiving the resetting instruction yet, because the resetting instruction only going to come from the Raspberry Pi. So now, so far the Arduino code we've written is working. Our counter variable is incrementing. It's gonna go all the way to infinity because we did not set the limit, right? So now we are now ready to move into the Raspberry Pi now and write a Python script that's going to be read a variable counter and reset it once it reach a value of 10. Then we send the instruction and then we're going to reset it. So that way we're going to test the receive data function if it is indeed working. Okay, so now we've got our counter running. As we can see, the counter variable is at 177. It's going up to infinity. So now the next thing for us to do is to be able to handle the variable counter into our Python script here on the Arduino side. I mean on the Raspberry Pi side. Okay, we have this receive data function that we've already written, and it was working on our previous tutorial. So what we're going to do is basically to modify where we are waiting for the data to be available on the serial data. We know that there are data available that the Arduino is basically sending to us. Okay, so if the USB serial, right, that is TTY USB 0, okay, that's where our Arduino is connected. So if that is the same as what we have hard coded here, okay, on our COM port, then we basically going to be able to connect and get some data. So what I'm going to do here, I'm just going to change the variable here and give it a name counter. Okay, so that's the variable counter. And then what I'm going to do is basically just to print and display the variable counter. So to do that, I'm going to just copy that and then paste it here. And here I'm basically just going to write counter is equal to string counter. So right now we can basically test it because we are already on our main here. We are connecting and we are receiving data. So let's see if we can run this Python script. It's obviously going to reset the Arduino and we are receiving. Okay, there is an error. We are not receiving. So what is happening here? My data less than 100. Okay, these line of code are basically throwing errors. Obviously they are going to throw errors at us, so let's go ahead and remove them. Then we can just comment them. Okay, so toggle comment out. Right, so we've commented them. Now let's attempt to run them again. Okay, it's gonna reset. Here we go. So the counter is indeed incrementing and we are getting it on the Raspberry Pi. Rather, every 1 second we are displaying. Now, how are we then going to reset this counter after 10, right? It's not after 10 seconds, but after 10 count, which we know it's after 10 seconds. But there is a way in which two methods that we can approach here. So the first one, we basically just going to, we can put an if statement here, right? So in this if statement, we can say if, right? Because we are basically getting that variable counter, okay? So we can say if counter, right, is equal to what? If counter is equal to 10, okay? Then we want to send the command to reset. Okay, so now we can take the command to reset the Raspberry Pi. So let me just take this here. Right, then we can paste it there. Okay, so we want to then write on the S data, we want to write. So the command that we want to write here is basically reset. Okay, now let's test this out. Okay, I'm going to stop it and then we're going to test it out. And also we want to also put another statement here. Okay, another print statement just for us to see. So I'm gonna copy. Okay, in the print statement here, we basically going to just say resetting, reset command sent. Okay, so the reset command is sent. Now let's go ahead and try to run this again and see if this is going to work. So this is a one method of doing it. All right, so we want to send, oops, okay, well, it did work, didn't it? We did reset, send a reset command. You can see there we go. You can see the reset command is being sent, but we are getting up to 11 there. So, and also on the LCD, when the reset command is coming, we are basically supposed to be getting a delay to display Pi counter. Pi reset. Okay, so I'm just going to fix that quickly here. So what am I going to do here? I'm going to just copy this line, and then I'm going to come onto the second line here, right? Auto format, and I'm gonna put 1 here. Then there I'm going to display the message, right? I'm gonna display the message, and here I'm going to just say Pi. So basically just what the Pi is sending, and I want to let it stay for 1 second. So let's go ahead and write that into our Arduino again. Okay, then we can test again. 3, 4, 5. You can see there is a slight delay between the LCD and there. Okay, command sent. But basically, let's not worry about the LCD. This is just an illustration, but we can see that we're getting command being sent, right, when the counter reached 10, okay, but we are getting another counter 11 being sent. So which means by the time we're sending the command to the Arduino, okay, the Arduino already have sent another counter variable 11, and this is what we are printing, this counter variable 11, despite the command being sent to reset it. Now the next method that we can try to mitigate that is to basically call the time function here, the import the time module on our Python script, which is already here. The Arduino is making use of the millis here to send increment a counter variable. Now we can now use a time now here so that we can check also for ourselves a 1 second delay, and that way we can see the discrepancies between the real time that's happening inside the Arduino and the one the Raspberry Pi is going to be counting, and then see if we're still going to get the situation that we are getting here. We are resending the command, but the Arduino already sending counter variable 11, which I mean it's working for us, although we can still try to make this better. So let's see how we can implement the other method. So I'm going to stop this. Right, we can see that the counter is still going on because there is no instruction to reset the counter coming from the Raspberry Pi, so we will continue infinitely. So what we're going to now do here is we're going to define the same type of parameters that we have on our Arduino. This time around we're going to use the time module into our Python script. Right, so this is the second method. So what I'm going to do here is so here we're just going to say previous counter. Okay, previous counter is equal to time dot time, because now we're making use of the time module. Right, now the next variable that we also need here is the delay. This 1000 is the millisecond, but in our side here we want to reset the counter after 10 seconds, right? So we then going to say counter delay. So we're gonna say counter delay. Now counter delay is basically 10 seconds, something like that. So 10 seconds. Now we can go into our receive data function where we basically working. Now inside here we need to record the time in which we starting to do our counter. So basically what I'm going to say here is I'm gonna say time, right? Time now. So now this is assimilating almost this variable that we say here, millis now. Okay, so time now is equal to time dot time. Right, then here we basically can call another if statement. Now in this if statement we going to emulate what we are doing here. Okay, so we going to say, well, if time now, if time now minus what, minus the previous counter. So that's the variable that we declare there. Now if that is greater or equal to what, the value that we want to reset. So this is now, in our case, this is the counter delay. So let's just go up there. So that's a counter delay, which is 10 seconds. Okay, so that is counter delay. Let's just put this into bracket so that it can make sense what we are trying to do here. Okay, so now what are we going to do here after processing? Exactly what we did here. We then going to say, well, the previous counter is then going to be equal to what? Time now. Just like this. Right. So now after doing this, we are now ready, because if this condition is true, right? If this condition is true, we got here, that means 10 seconds have a elapsed, or 10 counts have elapsed. Okay, assuming that the Arduino is also sending the data in that same time frame. So we then going to say, okay, we are now ready to send the command. Where to send the command to the Arduino? So in that, I'm going to copy this line of code, right, and paste it there, right? But I want to print this right after sending, so I'm going to copy that one as well and then paste it there. So now this is where we are now basically sending the command reset. Okay, so now to avoid problems here, I'm basically just going to comment out this one here, because we do not want to be sending the same instruction at the same time. Okay, we're gonna jam our serial port here. Okay, let's first stop this. Okay, and then we can just comment out this line again. Okay, now let's go ahead and give it a try. So we're going to run. Okay, so well, something happened there, and it says, so previous counter is reference before assignment. Well, this is Python stuff. Python like throwing this type of error if you do not define your variable right. So we have it already defined here now, but we are calling it here. So I think the way to fix this is basically to just declare them as global variable within the function here. So we say global previous counter, and then another one, because it's going to throw the same error. So this is a counter delay. So let's rather do it for both of them, counter delay. Now let me go ahead and run again, so we can see what's going to happen. Oops, there is another error that just been thrown. It says counter db delay. Well, this is a typo. This is just a typo. This is basically just a typo. Delay. Okay, so we give it another shot. Resetting standby counter. Okay, it is counting. Right, it is counting. So now let's see if we're going to send the instruction. Whoops, reset command send after just 7 seconds. Whoa, just after 7 seconds. Okay, so now it's 9. Reset command send. Well, is it going to catch up? Well, it's still 9. Okay, is it the delay function that I'm sending the reset? Is it perhaps that delay function that is causing a problem there? Okay, so let me just stop that. I'm going to just remove this delay, or maybe just make it a half a second, right? So I make it a half a second. I write the program in again. Okay, so now let's try again one more time. Okay, so we're going, obviously 4, 5, 6, 7, we send a command. Now it's 8. Okay, we are resetting the counter. 8. Okay, so we're resetting every 8 seconds rather than 10 seconds. So which mean, okay, so what is happening here is the time function here is, there is an accuracy issue here between the Arduino millis, right? They are not sync, and the time that now one of them is a real-time clock. So we'll assume that the Raspberry Pi will have some kind of a real-time clock running in there. Okay, and the Arduino got also a clock that is running after you reset it, but for some reason, obviously this is a transmission issue here, so both of them, they are not totally 100% sync. So which means if we need to let me just see inside my function here, the Python script. Well, we just have a delay here. This is nothing, so that's got nothing to do. It's not gonna influence anything. Okay, so let's reset the Arduino. Okay, so we reset. Okay, command send. So we're starting again. Let's see 7, 8, 9. Okay, it's still resetting at 9. Okay, let's see again 7, 8. Okay, so it is very consistent, both timer. So the delay is really so both timers are elapsing with basically a 2-second delay. So let me try to increase this one here, make it 12. Okay, and then we're going to see what's now going to happen after we make that one 12. So I'm gonna stop and run again. Okay, so now the Arduino did reset as well, because we're sending a reset command when we start a Python script. So now it's now at 9. Okay, and what is going to happen now, this time around 10. Okay, so it almost now catches it up. So now they almost are running in sync. So they're going to be now resetting after 10, and the Arduino is going to send the last command before receiving the reset. So it's now working exactly the same way when we had just with checking what the counter variable is, rather than checking the time now, right, with the time that now module on the Python script and the millis. So both of them in comparison between the timer that we are also transmitting data via the serial port, we can see there is like a 1-second delay between the two on the transmission. Okay, and I'm not sure, we cannot blame it on this timer delay, because even if I remove this timer delay, let's just remove the delay there, so that we can see that there is nothing else that is actually on the way of this transmission. So I'm removing that delay. Okay, so we can just have everything. Okay, let's first cancel that, stop that before writing in new data. Okay, it's been stopped. Upload complete. Now we can run again. Okay, so now let's go again. What is happening? It seems like, okay, well, there was just a glitch in there. 9. Okay, well, it is exactly the same thing is happening. It is exactly the same thing is happening. It's going to go again on that same format of resetting after 10, and then Arduino will send a command. All right, guys, that is it for this tutorial. If you find it useful, please give a thumbs up and subscribe to CMTEQ channel. Drop a comment in the comment box below. And if you have any suggestion on how we can increase the synchronization between the time that now on the Raspberry Pi and the Arduino millis, so that they can work more accurately, because as we can see, there is some discrepancies. It did work on both methods that we use, by rather just checking the counter variable or working based on the real-time clock on both sides. But something is going on and we can work with this. But if you have any suggestion on how we can make these two processors to have basically the same time synchronization, please drop the comment and the suggestion. Until next time, stay tuned for more tutorial on Raspberry Pi and Arduino interfacing. Cheers.